part 2 of the Anova assignment, and that is where we're going to make the null false. And the way you make the null false is you have to, I guess the first question is, what's the null? The null here is that these means of each of these groups, mean of A is equal to the mean of B, is equal to the mean of C, is equal to the mean of D, mean of E. Now, any one of these means is either larger or smaller than the others, or a number of them are sort of together, larger or smaller than the others. Then what we have is a null that's not true, right? So all we have to do is shift the means away from each other enough so that the probability of getting those total table variance estimates from the variance of the means is pretty small. So let's go do that now. So the way we're going to do it, I'm just going to go ahead and take this to another sheet. I'll show you. I'm going to take the whole. I'm gonna copy this whole sheet. So to do that, I don't have to do everything. Blah 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 blah. It's pretty easy to do here. I'm gonna do that. I'm gonna click Control C. You can also just copy the whole sheet if you want, which would be off of my screen. I'm gonna paste it in here. Let's see if everything landed in the way that I like it, and it did. I am going to change my view though, so that it's easier to see. Let's go zooming in. Oh yeah, 200% should do it. I'm going to have to back out to 175. There, perfect. So now we have a new sheet. I'm going to keep this information because we need that. We're going to still use the same random number, so I'll keep that posted up there. All the other information is the same. We still have an n of 10 here. We're still going to calculate the variance of means. We're going to calculate the mean of the variances. We're going to use the F ratio, and these degrees of freedom are all going to stay the same, actually, because the data points aren't going to change in terms of where they are. And even the p-value itself is going to stay the same. Because it's still going to have whatever's in this cell and this cell and this cell and true as the cumulative logical argument. So the next thing we're going to do though is modify the data. So I'm going to go to that first cell. So what I want to do is shift these things around. So instead of having, I want to take the mean. These are going to have a different parent distribution. What I'm going to do is I'm going to take the first group over here, and I'm going to make them a smaller group. I'm going to say let's draw them from a mean of 50. See how I just did that with one keystroke? Boom. Now that first cell has a 50 in it. So when I drag this down to this whole first cell, you'll notice, there we go. Now, these are drawn from a different parent distribution than B, C, D, and E are, okay? And what you'll see at the bottom is that the mean is close to 50 instead of being close to 60, which these other ones are. Well, they should be. Now I return to the next cell, and I'm going to make these. I'm going to make these numbers really. It's going to end up really different. So let's make these at. Let's take this one up to 65. To do this more quickly, I'm going to hit return there. I'm just going to change them all as I go across the top row. I'll make this one 70. All right, and I'm going to make this one 70 as well. And I'll make this last one 80. That's pretty arbitrary, the size of the difference I make. As you'll notice, if the difference in the means, if they come from different parents that are really close to each other, like 60 and 61 for the means, then you have to have a very small variance within groups to be able to show a significant difference. Now I've done this top row, but if you don't really know whether you have a big variance or a small one, I'm going to take the whole top row. Then you can just try some different numbers. If you try big numbers like doubling the means, I think you're probably going to end up with some really small p-values, which is fine. So now, hopefully, each of these cells will have, these are all from the 65, from 70, and this one's from 80. So now you've got a pretty good spread of means. And you can look at the bottom and see how they're calculated. They should represent pretty closely now. And here are your variances, still the same. Everything's still the same. Oh man, it looks like I did the p-value wrong. So I'll go in and fix that. let's go back over here and go through these really quickly. And now notice that your F ratio has gotten really large, right? Because now the variance of means estimates the parent distribution variance to be 1,300, which is enormous. That kind of makes sense, right? If the means are far apart, they must have come from a parent distribution that was really, really far apart, or sort of high variance, right? And that's what that predicts. Whereas the mean of variances hasn't really changed its estimate much at all. So the F ratio is large. The p-value is supposed to be super small, but I clearly made a mistake in my earlier functioning. I'm going to try to replace the true with a false. I thought I might be doing that wrong. There we go. So now this is 9.7 times 10 to the negative 8th, which is a very small number. Whoops. Okay, so that's really small, and then as we recalculate this a few times, you'll be able to see that, almost never do we get a p-value that's not super small, because we made the means relatively far apart for this particular study. So great. Looks like we're all set. I'm gonna stop.